In this video, I'm going to use an augmented matrix to solve the system below. What makes this different is that there will be infinitely many solutions. That is not at all obvious looking at this system. It's something that will emerge as we start our work. So to write the augmented matrix, I actually know that in this upper left-hand corner, I would love to have a 1 so that I can pivot easily. And I'm noticing the second equation starts out with a 1 as the x coefficient. So I'm going to write that one first. 1, 4, minus 1, 5. And then the current first equation, I'm going to put that second. 3 minus 1, 7, and 2. And then finally I have minus 5, 6, minus 15, and 1. And now I can use that 1 in the upper left-hand corner to pivot. I'm going to be taking minus 3 times row 1 and adding that to row 2 to get my new row 2. And I will be taking 5 times row 1, add that to row 3, and that'll be my new row 3. Let's work out the scratch work on that. So to do the minus 3 times row 1, that'll be minus 3, minus 12, 3, and minus 15. And row 2 has 3, minus 1, 7, and 2. And so when I add, I'm going to get 0, negative 13, 10, and negative 13. And so when I write my next form for the augmented matrix, the first row stays the same, 1, 4, minus 1, 5. And my new second row is 0, minus 13, 10, minus 13. I will now figure out my new third row. So here I was doing that work. Now I'm going to do this. So 5 times row 1 will be 5, 20, minus 5, 25. And the original row 3 is minus 5, 6, minus 15, and 1. So when I add those, I'm going to get 0, 26, minus 20, and 26. And that's my new row 3. 0, 26, minus 20, and 26. Now I'm in a position where I want to pivot in this position, and I'd like that to be the number 1. That's a negative 13. That's not 1, and I cannot easily get a 1 just by swapping rows. So I'm going to have to take, I'm going to get rid of that box. I'm going to need to take negative 1/13 times row 2 with a heavy sigh, because it means we are now going to enter fraction land, and we can't really avoid it. So that makes my new form of the augmented matrix 1, 4, minus 1, 5, 0, 1, minus 10/13, and surprisingly 1. And then the third row is again just 0, 26, minus 20, and 26. And so I will now be pivoting using that 1. I will take negative 4 times my current row 2, add that to row 1. That's going to be my new row 1. And this stays the same for row 2 and row 3. And that's going to be, this looks weird, but trust me, it's going to work out pretty nicely. Negative 26 times row 2 added to row 3, and that'll be my new row 3. So let's start doing some scratch work. Negative 4 times row 2 is 0, negative 4. That'll be 40/13 and negative 4. And when I copy row 1, that's 1, 4, negative 1, and 5. And so when I add, I get 1, 0. That's going to make for 27/13, and that's going to make for 1. So 40/13 plus negative 13/13 makes for 27/13. So my current version of this will now have as row 1, 1, 0, 27/13, and 1. Row 2 stays exactly the same, 0, 1, negative 10/13, and 1. And that's a coincidence. Those are both 1s. And let's figure out my new row 3. I said, trust me, this is going to work out nicely, and it actually will, thank goodness. So negative 26 times row 2 is going to be 0, negative 26, actually positive 20, and negative 26. And then row 3 is 0, 26, negative 20, and 26. So when I add, I get this surprising result of 0, 0, 0, 0. And so I have all zeros for my third row. At this point, I would normally be trying to pivot with that 0, but there's no way to get a 1 in that position. That's a 0. So this is now in RREF, reduced row echelon form already. So I'm going to switch this back to equation form. That tells me I have x plus 27/13 z is equal to 1. That's what this first row is telling me. The second row is telling me that y minus 10/13 z equals 1. And I don't have anything from the third equation, so I'm just going to write the fact that z equals z from that third equation. When I solve for x in equation 1, I'm going to have x equals 1 minus 27/13 z. I will have y equals 1 plus 10/13 z, and I have z equals z. And my claim is that is the equation of a line. It has one free variable, z, and that's what makes an equation of a line. If we wanted to make it look more like the equation of a line, I will simply replace the z. Whoops, that's 27. Let me fix this. So I have 1 minus 27/13. I'll call that letter t. Y equals 1 plus 10/13. I'll call that letter t, and I have z equals t, and that is my solution. It's a line. This line goes to the point 1, 1, 0, and has direction vector negative 27/13, 10/13, 1.